Hello, my name is Cynthia Ndukwe from your Math 1073 class, Section 16, Tuesdays and Thursdays from 6 to 7:15, and I'm going to be explaining how I got the answer for the project. And first we asked to find the decay coefficient so that we can figure out the time of death and the approximate time elapsed between his death and discovery. So to do all those things, we need to first use this equation. And then we're going to plug in these numbers. We're going to plug in 75 because we're going to be using time as like 1, because at 6 p.m. it was technically 0, because that's whenever they found him. So that's when they started counting. So at 7 p.m. it's going to be 1 hour past that initial time. So it was 75 degrees at 7, and then the room temperature was 70, and the temperature of the body was 80. And then we're going to solve this so that we can figure out K. So we're just going to do a lot of algebra to solve this. Then negative K, divide both sides by 10. It's going to be 1/2 e to the negative k. And then now that we're at this point, we can take an ln on both sides, so we can cancel out the e. So it's going to be ln of 1/2 equals negative k. And then instead of writing the 1/2 like that, we can go ahead and write the 1/2 like ln of 2 to the negative 1. And then we can take the negative 1 out to the front, and that's going to be negative ln of 2 equals negative k, and those negatives are going to cancel out, so then k is going to be equal to ln of 2. The next step is to find the time elapsed between when he was found and when he died. And to find that, we're going to use this equation here, and we're trying to find the time that he died, so we're going to be using 80, because that's going to be his temperature at the time. We're just trying to figure out the time that he died. And so we're going to use 80 here, plus the temperature of the room, plus the temperature that his body should have been whenever he did die. That's going to be 98.6 with the regular the regular human temperature. And we're just going to basically do the same thing here, just a lot of algebra to solve this. We're going to use our decay coefficient that we found. I'm going to divide both sides by 28.6. It's going to be 0.3496. And then now we can do the same thing we did in the beginning, and that is to take an ln on both sides to cancel out the e. And then that's going to cancel that out. And so we're just going to have ln of 0.3496 equal to negative ln 2. That's going to equal t. So we're just going to divide both sides by this so we can get the t by itself. And then when we do all that, we're going to get t that's going to be equal to 1.5. And that satisfies b, because b is asking the time elapsed. So basically 1.5 is going to be like an hour and a half. So that's going to be like the time between whenever he was found and whenever he actually died. So if we take that information, he was found right before 6, so it's basically 6. And then there was an hour and 30 minutes between the time that he was died and he was found. So that's going to mean that at 4:30 is the time that he died. Thank you, and I hope this all made sense, and that's all. Thank you.